right? And I facilitate discourse. I facilitate discourse because there they are. You can't see that, so I'm going to put it in this form in a second. That's Kendra Scarborough's room in Hazelwood, north of St. Louis, Hazelwood, Missouri. Kendra's a 6th grade teacher. How do I know that? Because you've got all the connected math stuff sitting on both sides of those clouds. Note to self. Go back and start the year with a set of discourse clouds. Every one of your classrooms needs to have. Why? How do you know? Explain that, please. Can you convince us? How did you picture it? You don't like the clouds? Then fine. There they are. If I could wave a magic wand and get every one of those 9 questions regularly to come out of your mouth, I start with why. Why? How do you know? I move to convince us. Less is more. I'm not doing 10 problems. I don't need to do 10 problems. Look at what Ali and Mabuber did with 3 problems. And so I'm forever dealing with how do you know, where did that come from? And then Max Ray, the wondrousness of what do you notice, what do you wonder? Every time I ask kids what do you wonder, they supply better questions than the one that's in the problem in the first place. How are they the same? How are they different? Show me your work, show you your work. And now we are focusing on the discourse driven by those questions. We pose purposeful questions because there it is, gang. Everything I've done today reminds you that the challenge we face is to remember that good math begins with an answer, often the wrong answer. And that it is our explanations and our connections and our alternatives, that's what makes the difference. Yes, of course an answer. And it really shouldn't be versus. It should be answer getting versus, and then we put them all together in this way. And we build fluency from conceptual understanding. There it is. Go. Well, of course, everybody knows what to do. Right? God says, subtract 7 from both sides because that's the way you do it. And the kid sits there and says, why can't I divide by 3? A bad teacher says, you can't do that. It's not the right way. A good teacher says, let's try it. Maybe we'll play with fractions for a little bit. Why can't I divide it all by 3? You know I can. It's not one right way. But no, I subtract 7 because that's the only way to do it. And then I divide by 3. Oh, nice, I divide by 3. And then I get this wonderful answer. What do you do when a kid doesn't understand that? You say it louder. Right? You sprinkle it in softer. There it is. Look at that. There's this notion of what's on the left. What 3x plus 7 is an expression. In an expression, I go, well, if x is 0, if x is 2, if x is 5, how do I get it? What does x have to be? And so I say, wait a second, there's another way to think about this. Think about some guess and check. Think about what we're trying to do with all this stuff. I sit there and say, wait a second, look at this model. Look at how I start with x, right? I start with x, and then what do I do to x? I multiply by 3, correct? And then I add 7, and somehow I get 22. Look at the left side. Look at how I have a diagram that really models this idea of doing and undoing. Hear yourself saying what you do and then you undo. We never really talk about what doing means. Doing means assembling the expression. And then somehow, magically, at some point, with some value, it's equal to 22. So look at how I start with x, I multiply by 3 to get 3x, I add 7 to get 3x plus 7, and then that's 22. I undo by going backwards. So instead of multiplying, of adding 7, I now subtract 7. A different way of looking at it. And every one of you knows that you have kids that unless you do this, unless you go to hands-on equations, unless they see the scale and the balancing thing, then none of this ever makes sense. Again, different representations, again, this critical notion of helping kids make sense through building fluency on how to solve an equation based on understanding what's going on. And then we've got a struggle. And I don't have enough time to do the struggle today. So in your spare time, you can go play with this problem. This is a problem that we've been using in Success Academy in 6th grade. It'll blow your mind. Forget it. And evidence. I shouldn't have to say any more about evidence. In fact, I suggest that you start the year off with the evidence chapter. You start the year off with a missing piece. You start the year off with the part that in fact we talk about and then don't do. You read those 7 pages and you make personal and collective commitments. You bring your principal in, you bring your coach in, and you say, help me with this, let's make sense of this. How difficult is it with 5 minutes left in the lesson for you to say, or I've signed 2 5-minute markers, 2 5-minute monitors, and with 5 minutes left, it's as simple as, okay, go and tell your partner what you learned today. Nice, let's see if you've learned it. And the kids put it on little Post-it notes, and then we collect it, and we look and we see. I can't tell you how rarely I hear a lesson start with the words, based on yesterday's exit ticket. And so that's the way to do it. And I need now to put it all together. I need to say to you that, so we wrote this stuff, and I'm trying to implement it, and it's not working so well. And I'm struggling with how to make it accessible. And over the past 2 years, most of my life has been reduced from a room with 300 people to sitting with 6 sixth grade teachers for 3 hours. Last month in Omaha, sitting with all of the Algebra 1 teachers at Bryan High School, 6 of them, for 3 hours. And what we've been doing is we sit there and say, what are you trying to accomplish today? What do I think professional development is? I think the professional development that you can model in your own school sites. Professional development is, we spend an hour talking about the lesson we're about to teach. We build a set of slides. I teach the lesson because I want you all to watch, your kids. I want to have fun playing with it. And then the most important piece of all is the last hour. After I teach it, there are only 3 questions. We can go for 4 hours if we had it. We only have 1 hour. What worked and why? An amazing discussion. It was amazing, this happened. You did this worked, this worked. It was so good. Why did it work? Why do you think it worked? What's to prevent you from doing that? 2, what questions do you have and how could that have been done better? Because there is no such thing as a perfect lesson. And the last 20 minutes, what 1 or 2 things can you do or will you commit to doing differently on the basis of the 3 hours we spent together? And so I want you to see, what are you trying to accomplish today? All right, good. Once you tell me that, then you go and frame your opening slide. Good. What would students be able to do to convince us that they've learned it? What a great set of questions. This is planning. This is real planning. This is honoring this vision of, you guys are blessed. You are not like tomorrow. You are not like the elementary teachers who teach a lesson once a year. Almost every one of you plans a lesson and gives that lesson 3 times tomorrow. Every one of you has a chance to refine it. Every one of you knows that you screwed it up, you fix it, you change it in between classes. You know that you do that at the end of the day so that they're ready for you next year in a better form. You know that in powerful departments there's a repository of PowerPoint slides and our unit assessments that guide what we do. And so, what would students be able to do? All right, nice. So we draft or craft the formative assessment exit ticket slide. Then the question is, how do I get from one to the other? What is it that will allow kids to show me that they can do what we want them to do? And lo and behold, I spend most of my time stealing and crafting these task slides. Okay? I go to the tasks, the examples, the problems, the activities. What will students be engaged in? What maximizes the chance that they'll successfully meet these goals? And we go and craft them with the questions and with the discourse and all the representations that we need. Good. And then I say, yeah, but they ain't going to be able to do that unless they have this prerequisite knowledge. I'll go and create my warm-up slides and I insert them. That's all it is. And then I end up with what I'm going to share with you. The most exciting stuff I've been doing is watching as kindergarten, 2nd, 5th, 9th, 8th, Algebra 2, pre-calculus teachers come together and say, look at what I've got for you. I've got my objective or lesson goals slide where I've underlined the key vocabulary. I got my warm-up slides to get the blood flowing and to take care of prerequisite understandings. I got my task slides with my questions and all the necessary graphics, and most of them are animated. I then end with what did you learn today and with my exit ticket. Good morning, my bright-eyed, bushy-tailed geometry students. What are we doing today? Blah, 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 blah. Nice, all right, so we're going to classify quadrilaterals. We know what they are. How nice, good. I stick this in there because you know what? I know that if I'm going to talk about properties, and in fact this comes up when I say to the kids, what are properties? Well, you know that we give kids a graphic organizer. We help kids. We stop and realize that instead of remembering it, instead of guessing about it, all of the properties about quadrilaterals have to do with opposite sides, opposite angles, diagonals, adjacent sides, congruent, parallel, perpendicular, and bisect each other. There it is. Now can you apply those things to the kite, and to the parallelogram, and to the rhombus and those things? How nice. Not sure we're ready for this. Lines M and N are perpendicular. Turn and tell your partner, identify two other things about these two lines. How am I going to do properties? How am I going to make sense of these quadrilaterals? How am I going to differentiate a parallelogram from a rectangle or a rectangle from a square unless I can sit there? No, this is not turn and tell your partner. This is on your whiteboards. Go. Two other things. And I'm wandering around and we see what kids write and I see what they don't know and I nudge kids that are not paying attention because I need to get the blood flowing. Good. On your whiteboards, draw two parallel lines that are transversal. Identify one pair of alternate interior angles. How hard is that? That's all a warm-up does. It says, I'm in trouble if you can't tell me these things. Right? They're done on your whiteboard. You can draw them. I can hold them up in all these different ways. I can read them. Good. Number 3 on your whiteboard, draw a pair of vertical angles. Good. Nice. I see an X. I see a Y. I see a Z. Which ones have vertical angles? Which ones don't? What says? Where are they? All that kind of stuff. Good. Number 1. What am I looking for? Come on, gang. Number 1. What? Identify two other things about these perpendicular lines. Good, they're perpendicular, they're orthogonal, they need to form right angles, they need to form 4 equal angles. Their slopes are negative reciprocals of each other. Whoa! Look at that. I got one kid fixated on slopes and all that stuff and reminds me, because I don't remember that one. So again, the cumulative review makes that sense. All right, now let's warm up. Good, turn and tell your partner, right? 3 properties of a rectangle. I don't have any time to waste. I have everything I need to do so that my first 10 minutes of the class, bing, 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 turn, talk, get your brains on. I can't do quadrilaterals unless they can tell me properties of a rectangle. How are kites and rhombi the same? How are they different? The sum of 3. This is not my work. This is 6 people coming together over the course of an hour at, I don't even know what school, did it say what school this was in? Where was I in January? You have no idea. I do know where it is. This was at the American School of Barcelona. I know where I was the end of January, right? I know. On your whiteboards, draw 3 of them. We did that one. We warm up, right? We got the warm up, right? In other words, I'm stopping and thinking about 10 minutes of instruction to take care of prerequisite understanding, to lead up to what's going on, to do the warm up that has nothing specifically to do with today's lesson. The sum of 3 angles of a triangle must be, how do you know? Oh my goodness. All right, on your mark, get set, we're ready? True or false? On your whiteboards, I want to see a big T or a big F. All squares and rectangles, explain your reasoning. You know how hard this is. You know how crazy this is. You know how important it is that kids be able to do this. You know that I can't categorize quadrilaterals unless we're able to talk about what's going on. You know how many kids sit there and go, there are rectangles and there are squares. And they don't overlap. And if it's a square, it can't be a rectangle. Why would it be? It's a separate thing. And yet the notion of properties, this notion of a hierarchy, look what I'm doing. I'm really using geometry to strengthen their brains in such powerful ways. True or false? Good. One more. All rectangles are squares. Whoa. And so it sits there and we think about how that comes straight out of my textbook. It's sitting in there. It's one of the C problems in my book. So I put them on a slide. I think about that being a great way to start this lesson. And then when it doesn't work, guess what? I go and adjust my slides so that they're better the next time I teach it. And now go. Complete the quadrilateral family tree of the partner. There it is. Right, now go do the tree. Start with a quadrilateral and then show me about parallelograms, and I'll tell kids I want to see in the tree where is a kite, a square, a quadrilateral, all those kinds of things. And when done, tell me about your tree. Describe your tree in some way. And then I go to Google and I go find this quadrilateral sort. Use your quadrilateral family tree and your knowledge of the shapes to sort the quadrilaterals in your envelopes into groups. Look at that, gang. It comes straight out of, there it is. I don't need to go to Best Lesson. I don't need to go anywhere. All I have to do today is go Google. And I go Google quadrilateral sort. There are 9 different ones to pick from. I like this one. It's clean. Right? I have that up there, but meanwhile, every kid has one pair of scissors. Or I cut them up because I don't have time for them. I don't trust my kids with scissors. So I've had some weird kid who's in detention, or I got that wonderful little Priscilla who loves to help me, right? And so Priscilla cuts them all, put them in an envelope, right? And then we go sort them out in all different kinds of ways. And how did you sort them? And how did you sort them? I have a task. I have a task that I know works. I have a task that is driven by the questions that I then ask. There it is. Turn and tell your neighbor what you learned today. Let's see if you did learn anything, and there it is. I have purposely not adjusted any of these lessons that I have developed with teachers all over the country and all over the world. Because they're not perfect. Because they are first approximations, or they're second approximations. Make a few adjustments, sometimes we do them twice. I need you to see how we have a mechanism to put all of this disparate stuff together. We have a chance to think about the goal, the task, the discourse, the questions, those aspects of quality instruction, so that now I can do a demonstration class even though I don't know the kids. I can walk in and use these slides because everything I'm going to do is sitting there. I don't have to think about what I'm going to do. I don't have to think about what question I'm going to ask. My slides are animated and all that stuff. It means I can focus on what the kids are doing, and that is the giant leap. All of you remember, the first year you taught, it was not about anything except you. Kids, they don't exist. I gotta teach. I gotta be in control. I gotta do all this stuff. Second year, somebody says, you know, that's really good, except that, what about the kids? Are you paying attention to what they're doing? And you go, I have no time for that. It isn't until like our 5th year that we realize that I got it down, but it's about the kids. These slides now allow me to focus on my kids and about their learning in all those kinds of ways. Right? So now I'm in grade 6, right? You know, they never told us in teacher prep school that review lessons are nightmares. Review lessons are just different species than anything else, right? So I get challenged by a group of 6th grade teachers, right, to take this monster thing called fractions in 6th grade and build a set of slides for a 1-hour review lesson. Okay, cool. Lesson goal, be sure we're comfortable multiplying and dividing with fractions. Fair enough? This isn't even a year ago, right? February, right? Sat there and did this is SAS Pudong is the Shanghai American School. Look at that. This is collaborative discussion. This is a review lesson. What good is it if kids can't tell me what it means to multiply? Now that's taking a risk. But I mean, this is the kind of thinking that kids need to have, right? What does it mean to multiply fractions? What are we looking for, right? What do we want kids to be able to tell us about this kind of stuff? Good, right? Ready, set, true or false? Oh my goodness. Look at this. I hate true or false test items. I love true or false when it comes to test review. I love putting up a problem that's absolutely right. I love it that the kids go, well, obviously it's right because 3 times 2 is 6, and 8 times 3 is 24, and 6 over 24 can be reduced to 1/4. And I go, awesome. So how'd you get that? We multiplied the numerators, we multiplied the denominators, and then we simplified. And I go, oh, great. So multiplying fractions is the easiest thing in the world. If only adding and subtracting was that easy, good. The rule tells us to multiply fractions, we review the rule. But I'm not nice. What does it mean that the product of those 2 numbers is 1/4? You see what I mean? That math begins with an answer. You see what I mean? That these are questions that most of you in this room are saying, I don't know. I'm not going to ask a question that I don't know. And I'm going to tell you that great teachers have always asked kids questions that they don't know the answer to. And then let the kids wrestle with it. You have kids that can come up with amazing things for this. At your tables right now. Last time I'm going to ask you to actually think at your tables. Ready? Answer that question at your tables. Take some risks. What does it mean that the product of 3/8 and 2/3 is 1/4? Go. That's why we need to accept the fact that there is no reason for all of us to know everything we need to know. That is why we have to have collaborative structures. That is why my last question on here is, so, if you forgot the rule, what are you going to do? Because most kids think if they forget the rule, they're screwed, they're dead, they can't solve it. This question you're wrestling with is, if you forget the rule, how do you find it out? So here we go. What does it mean? Volunteer. What does it mean that the product of those two fractions is 1/4? There are 5 different good answers. Okay.
So we started with the problem, what does 6 times 2 equals 12 mean?
Oh.
Because fractions
6
are hard.
times 2 equals 12, so I know that.
I have 2 groups of 6.
Nice. Therefore?
So that means 2/3 a group of 3/8 is a fourth of the group.
Look at that. Look at the way in which now, you're hearing that, and most of you have no idea what she said unless you thought it the same way. You know you want a picture. You know the picture of seeing that 3/4, right? You know that what she just did is she said, wait a second, that if I know that 6 times 2 is 12, right, then how did you go to 3/4 of, wait, what does it mean, the product of those two? So it's 2/3 of 3/8. Well, wait a second. Oh, wait a second. 1/3 of 3/8 is 1/8. I'll be darned. Stop and think for a second. So 2/3 must be 2/8 or 1/4. Wait, that didn't work for you. That didn't work for me. Show me another way. What does it mean? Asking those questions is part of the review, helping kids understand what's going on. Super, right? So we forgot. And then what does it mean to divide fractions? All right, I do the same thing, true or false. It's all right, I got a mixed number, right? These are 6th graders, this is the stuff they need to know, and so you're going to take a test on this stuff. And so the rule tells us that invert and multiply. Real helpful until you can't remember what to invert. What order do you do it? All that stuff. And so again, convince me. What a great question. Convince me, I don't care about the rule right now, convince me that 1 3/4 divided by 2/3 is 3.5. Are you not sitting there saying that you would hope every kid would say to you, how many 2/3 are in 1 3/4? Are you not hoping that every kid can draw some kind of a bar or a picture to be able to do that? Are you not recognizing that if I don't help kids see it with a number line? So all I'm doing is saying to you that it is my deep and abiding belief that the real value of these 8 mathematical teaching practices is the way in which they get translated into our daily practice with one result: better teaching. Because if I can wave wands and get better teaching, we know we get better learning. And we know that people blame us. People blame teacher prep. I am so tired of teachers being blamed when we are given no opportunity to grow, no opportunity for quality professional development, no time to do this kind of sharing, and then we get screamed at for not making a difference in kids' lives. And so that's what we have to worry about. That's what we need to do as professionals. That's how we need to be. So, do we multiply or do I divide, right? Sarah's cookie recipe requires 3/8 of a cup of sugar. You know it's a review. What's important? What's important is when I give you the question, you multiply or do I divide? So we sat there and said, what do they screw up on? What do they mess up on? What do they not know? And so, my review, part 3, right? Sarah's cookie goes with 3/8 of a cup of sugar for each batch. Sarah has 10 cups of sugar. What's the question?
Does she have enough sugar?
Does she have enough of the recipe? Right. How many batches did she make? More than 10, less than 10? Come on, gang, more than 10, less than 10?
More.
That was fast. How'd you know more than 10? You didn't do any division. Come on, somebody tell me why it's more than 10. Yeah, because each batch is less than half. Right? I mean, each batch requires less than half a cup of sugar. So I'm going to actually have more than 20 batches if I did it all. Oh, how nice. Look at that. So what's the question? You asked the question. I'm always putting that in there. Right? The question is, how many batches can I make? How do you know? Do I multiply? I could multiply and find the missing product, or I can divide. Why am I dividing? Because I have the whole. And so it's just a matter of, look at how I'm trying to show you tasks and questions and discourse. Look at how we're building fluency based upon understanding, not memorization. Look at how my slides, and what's the question, what's a reasonable estimate, get at all of those aspects that are so critical, right? Your turn. And now we see whether you can do it, because in the end, I gotta have kids who can go and tell me what's going on with this particular problem. I have kids this, now go do this one. Make up a I love this, right? Make up a realistic problem. Make up a realistic problem. Why do we not recognize that the kids ought to be able to make up a problem to be able to do that, right? Why does the rule work? Turn and tell your partner why invert and multiply works to divide fractions. If you can't tell me that, my lesson has basically not worked. Sentence completion. Here's a different way. Instead of what you learned today, right, in a review lesson, I say the biggest or most troubling question I have about multiplying dividing fractions is, and tell your partner what you learned today. What do I need to know to be sure I'm going to be successful on tomorrow's test? I give you that as another example of what your colleagues have put together to try and make a difference in kids' lives. And so I got one more on here that I'm not going to do. It's just not important to go do this problem. I'm going to race through it, and it's not important. You can go see it. We play it out those ways, and turn to tell your partner. But so there it is. There is this template for lesson planning. There's the template for implementation. There's the template for coaching. There's the template for collegial analysis of what we do. Gang, before I say thank you, we have 5 minutes. At your tables right now. The single biggest question that I have on the basis of enduring almost 3 hours of Steve Leinwand is, I'll say it again because you didn't hear me. At your tables, contribute. The biggest concern that I have about the things we've talked about on the basis of all we've done this morning is complete that sentence. Go. Biggest concern, biggest question. Ladies and gentlemen, you can tweet this out to your heart's content. Professionals are not sheep. Professionals do not wait for somebody else to tell them what to do. Professionals recognize that we have one and only one responsibility, and that is to produce a generation of American citizens who are far more facile in mathematics than the current generation. I'm here to tell you that the 6 of you who constitute the middle school math department, the 7 of you who constitute the high school math department, when we say we are going to let kids use Desmos on their graphing calculator, we are going to rearrange the room into groupings of 4, we are going to do, they can't fire all of you, they can get angry at you, but when the scores go up, the kids win. I am just so tired of hearing you say, I can't. There is power in numbers. You have a responsibility to go back and be part of the leadership group in saying, I'm going to try it. I'm going to videotape some of what I do. I'm going to share that. I'm going to walk into other people's classes because I don't have to use my prep period on Friday. And on Friday, I ought to be able to walk into any class in the school. Raise your hand if as a math teacher you've walked into a reading language arts class. There you go, gang. It is unbelievable to see what they're doing. How many of you walked into a science class? There you go. How many of you have never walked into another class? Don't raise your hand. Right? That is the building of collaborative structures. When I said to you, what's your biggest concern? What's your biggest question? The first order of business is that question can be answered within our departments. That question can be answered by going onto a website. That question can be answered through Twitter. That question can be answered by sending me an email. I spend an hour and a half every single solitary day responding to email comments and questions. I consider it to be the height of irresponsibility not to respond within 48 hours. I just think that that's what we do. We support each other, we move things ahead, we make a difference in kids' lives, we use these principles to actions as a resource. Go forth and better teach your students by making more effective use of these standards.